Did you ever hear phrases like agile is not faster or you have to do unintuitive things to become agile? Did that make sense to you? To me, in the beginning, stuff like that made no sense to me at all. But now I think that those things are the main reason why so many companies fail to become agile. They implement agile software development only to become faster, but they do not understand some of the most important underlying principles. Today, I want to talk about a very important but also very unintuitive principle. We must slow down to move faster. My name is David, and in this video series I'm talking about things you can do to become a better software developer. I'm a freelance consultant and coach, and in the last 12 years I've tried to constantly improve my skills and learn more about software development and software architecture, but also my skills as a tester and team coach and trainer. And many of the things I learned were hard to grasp for me at first, because many of the things we have to do to become better make no sense at all, until you think hard about them and try them and learn more, and suddenly they are perfectly reasonable and the opposite doesn't make sense anymore. For example, today's topic: slow down to move faster. Today I want to talk about how agile software development is not fast, but it can still be worthwhile because it enables you to deliver more value in less time, which means it is faster, although it is slower. Confused? Me too. Let me start again, this time a little bit slower. Many things we do in agile software development seem to be slower than in a traditional project. We do some planning, some design, some meetings, some architecture in every iteration. We even change our architecture and design often. This definitely adds some overhead. We take more care when writing code. We write a lot of tests, we run them often, and we rethink our design decisions after every green test. We spend a lot of time automating things and testing that automation. We automate regression tests, user acceptance tests, performance tests, deployments, and even releases to production. And we work in pairs or even in small groups. 5 people working together on the same feature, maybe even on the same line of code, that cannot be possibly faster than 5 people working in parallel, not getting in the way of each other. And yet, it often is. How can that be true? How can slowing down make us faster? Let's look at 2 hypothetical teams. Team Niagara works in a very traditional waterfall, plan then do then integrate style. They have a command and control structure and they do exactly what they are told or what was written down in the plan. Team Gazelle, on the other hand, is more agile. They iterate quickly, they try to get something out of the door, they try to get good feedback early, they change direction very often, they don't even know at the beginning where they will go exactly, they just try something and get feedback. And we ask both teams to deliver 5 features for us: A, B, C, D, and E. Team Niagara first plans the project. They create a detailed project plan, they sketch out their software architecture and design, they decide who will work on what, and they also do project preparation work like setting up the repositories, build servers, IDEs, working environments, and so on. Then they start to implement the features. They first implement A, then B, C, D, and E. They integrate and test everything and fix some minor bugs, and things went mostly as planned, so they released to their users. It took them 7 weeks. Team Gazelle, on the other hand, does a little bit of project preparation work, a little bit of architecture, and then they immediately start implementing a very basic version of features A and B. They integrate all the time and after a week they release what they have to real users. The users cannot really use the software productively yet, it is way too basic, but they give some feedback, and from that feedback Team Gazelle learns that users right now really need D&E. So the team works on D&E next, but they also need to do some more project planning, software architecture, software design work, and even some project preparation work that was not finished during the first week. After a week, they release D&E to users, but a very basic version that they cannot use productively yet. But they already see that users like it and they want more, so the team works more on D&E. And while they are working more on those two features, the users report some bugs. They seem to be really trying the software. And Team Gazelle fixes those bugs, those defects right away. During the next review, where the team gathers feedback from other stakeholders, some friendly users agree to use the software in production now because it already has enough functionality to provide at least some value. Also, someone from operations brings usage statistics, and he suggests that it is already clear that the current implementation of feature E will not scale. Now the team addresses those issues. They completely redo E and they start working on feature G. They also do some minor corrections to D and they fix some defects. And this cycle of implementation, feedback, replanning and releasing continues until after 10 weeks they are done. So delivering the software took longer with the Agile approach. And the team did not even deliver feature C at all. Was that really better? Well, the story doesn't end here. With software, it never ends right after the release. On the day after the release, Team Niagara starts to get some phone calls. They have major scaling issues. They have slowdowns and even production outages. They work night shifts to create the quick fix and then work even more to create the real solution for the scaling problem. They have to completely re-architect feature E that causes the problems. But some design decisions they had to put in place for feature C make redoing feature E harder, so it takes even longer than during the first time. While they are working on that, bug reports keep rolling in, so they also start fixing those issues. And users complain that the software does not even allow them to do their job better. Some major part at the beginning of each workflow is missing. Management decides that they really have to implement feature G. But because of all that code in place, the code for feature C, the hastily redone feature E and all the bug fixes, implementing feature G is quite hard at that moment. After the next hotfix, the team analyzes some usage statistics and they realize that only a tiny portion of the users are really using feature C. So to make future maintenance easier, they decide to remove a part of feature C. During that time, Team Gazelle has already moved on to the next project. They are only doing some minor fixes for this project and they gather some feature requests for the next major release. In the end, considering everything, they delivered faster and cheaper. They are now ready to move on to the next major release and they were able to provide some value in another project while they had some slack. One could say that Team Niagara made mistakes during requirements engineering and software architecture, that they should have foreseen those things that made them slower in the end. But there will always be unforeseen things. Even the best requirements engineer or software architect cannot anticipate everything that could ever happen. So by getting feedback early, being able to react quickly, and always emphasizing high quality code, architecture and tests, the Agile team was faster. In a future episode, I want to talk in more detail about some aspects of this episode. And I want to answer your questions So ask them right here in the comments or ping me on Twitter. I am the Tancer there. And do not forget to subscribe to this channel or follow me on Twitter so you do not miss any updates.